Bismillahirrahmanirrahim. So our today topic, as you said that is the periodic table. So first of all, you should know that what is a periodic table if you are going to define it. They are saying that periodic table is a diagram of elements, or you can say it is an arrangement of elements in which they are arranged according to their increasing proton number. You can say it proton number. You can also say it is atomic number. And what is the meaning of proton number? Means number of protons in the nucleus. So this is the periodic table. So simply, periodic table is an arrangement of elements according to their increasing atomic number or proton number, and also they are arranged according to their properties also. So if you will go, for example, if this is a periodic table and you go in the periodic table from left to right, then proton number increase. So here you'll find 1, then you'll find 2, then 3, 4, like this. So it is increasing from left to right. So two things are very important in the periodic table. Number one is group, and number two, the period. Group means vertical columns. For example, if I draw the periodic table, I will draw like this. So these lines, for example, these columns, they are known as groups. And if you talk about like these rows, which is going from, you can see here, this side, they are known as periods. So once again, the vertical columns in the periodic table, they are known as groups. Vertical means like this, from top to down, these ones. And horizontal rows mean these ones, so they are known as periods. So if you talk, now we will see again the group in more detail. Now see, group element in a group have same valency electron and similar chemical properties. So here, first I will define this part. For example, now group 1. Now they say that, now see which are in the first group. First group is hydrogen, then you have lithium, then you have sodium, then you have potassium. Now they're saying that elements which are in the same group, they have the same number of electrons in the last shell. How? For example, see hydrogen. Hydrogen has 1 electron. If I want to write its electronic configuration, I will write 1 because it has only 1 electron. Other is lithium. If I want to write its electronic configuration, I will write 2 and 1 because it has total 3. So first shell 2, then 1. If I want to write sodium, so sodium has 11, 2, 8, 1. If I want to write potassium, so see potassium has 19, means 2, 8, 8, 1. So if here you can see that the last shell of each one, they have same number of electrons. So if any element in group 1, if you see the valence electron all have 1, 1. Same goes to group 2. For example, first one is beryllium. It has total 4 in first 2, second 2. Then you have magnesium. Magnesium total 12. First 2, then 8, then 2. Then you have calcium, 20 total, 2, 8, 8, 2. So here you can see that all of them, they have 2 electron in the last shell. So why they have 1, 1? Because all of them, they belong to group 1. they have 2, 2, it means they belongs to group 2. So here they want to say that from the group number, you can tell the number of electron in the last shell. For example, if group number 1, it means all these elements which are in group 1, they have 1 electron in the last shell. If group 2, if they are in group 2, it means that all of them, they have 2 electron in their last shell. Same applies to go group 3, group 4, group 5, group 6, like this. Group 7 and group 8. 8, we will not see this one because it's a noble gases. So their last shell is complete. So we will see this one there, which has not complete. Any confusion till here?
No, no confusion.
Okay. Okay. So here they are talking about the same thing here. So now you can see the new page.
Yes, Mr.
Okay. So here they're saying that now the classification of elements in the periodic table. So if you want to divide the elements in the periodic table, you will find 2 main categories. Number 1, metals, and number 2, non-metals. But there are some elements which are very few in number, but still they exist. They are known as semi-metals, or they also known as metalloids. What do you mean by semi-metals? Because these elements, they show both properties. They show both properties, metals and non-metals. So they are known as semi-metal, or they are known as metalloids. Any confusion till here?
No confusion.
Okay. Now they're saying that if you see metals, metals are found on the left side of the periodic table. For they are talking about group 1, group 2, then group 3, and in between this one, they're talking about. So mostly the metals you will find on left hand side of the periodic table. On the right side, you will find the non-metals. And between the metal and non-metal, you will find the metalloids or semi-metals. Now we will see the properties of metals, and we'll see where they are found. Number 1, metals, they are spread mainly in group 1, group 2, group 3, group 4, plus transition metals. Okay, now I will show you again that periodic table. Can you see the periodic table?
Yes, we can.
Okay, now they're saying this is, if you divide the periodic table, so this is the left hand side of the periodic table, and this is the right hand side of the periodic table. So they're saying that metals mostly the left side of the periodic table. Now group 1, group 2, group 3, they are metals, and this part, this blue one, they are known as transition metals. They're metals, but they are not in any group. They are known as transition metals. They are metals. And after that, some of group 4, and after this side, non-metal starts. So you know group 1 is metal, group 2 metal. These are transition metals, and group 3 is metal. And from group here, you will find like silicon, germanium, this one, they are like a staircase and periodic table. They are metalloids. I'll show you another diagram more clear. Understand now? So again, can you see the new page?
Yes.
Okay. Now they said that metal, they react with oxygen to form metal oxide or basic oxide. Remember in the previous chapter in acid base, we said that metal oxide are basic in nature. Other property, the metal, they react with non-metals and form ionic compounds. So these are two main properties of metals. Now non-metals, they are mainly found in group 5, 6, 7, and 8. They are separated from the metals by semi-metals. What are their common properties? They react with oxygen to form acetic oxide or non-metal oxide. They react to form covalent compounds, and with metal they form in ionic compounds. If non-metal react with a non-metal, so they make which compound? Covalent compounds. And if a non-metal react with a metal, when they form ionic compounds. So this is the main difference between them. After that, what are the semi-metals? Now, see here. Semi-metals, the metalloids with properties similar to the metals and also to the non-metals. Metalloids includes boron, silicon, germanium, arsenic, antimony, tellurium, polonium. So these are all the semi-metals. Okay, you can start from here. They start from boron. I will just show. Can you just see the screen?
Yes, we can.
Yes, now see here. This 1, 2, 3, 4, 5, 6, 7. These are the semi-metals or metalloids. They have some properties of metal and some properties of non-metals. So in your book also they have defined in the periodic table. Any confusion?
No confusion.
So if you see this side, all this side, these are metals, and this side they are non-metals. It means that non-metals and metals, they are separated by these semi-metals or metalloids. Now here we will discuss some properties of metal and non-metals together. See here, what is the first property? Physical state at room temperature. When they are talking about room temperature, it means 26 degrees Celsius or sometime 25 degrees Celsius. So metals, mostly you will find the metal, they are solid at room temperature, except the mercury, which is in liquid form at room temperature. Non-metal, some of them, they are solid and liquid or gas. They are found in 3 states. If you talk about density, metals have high density, and the non-metal, they have low density except carbon in the form of diamond and graphite. These are exceptions always there. If you compare them in terms of melting point and boiling point, metals, they have high melting and high boiling point, whereas the non-metal has low melting and low boiling points, again except carbon. If you talk about electrical conductivity or the heat conductivity, mean they allow the heat or electricity to pass through them or not. If you compare them in this scenario, it means that metals are good conductor of heat and electricity. It means metals allow the heat and electricity to pass through them easily. But if you talk about non-metals, so they are poor conductor of heat and electricity. Only one non-metal which conduct electricity, that is graphite. Graphite again in the form of carbon. After that, malleability. Malleability means you can convert them into different sheets. For example, you have an iron piece. If you compress it, you can convert into different sheets. So metals are malleable. Malleable means they can be converted into different sheets. Non-metal, they are brittle. Brittle means if you want to press them, if you want to apply the pressure, so they break down into pieces. They will not become sheets. They will break down into small pieces. So it means brittle. Ductility. Ductility means converting into wires. Ductility means something can be converted into wires. Metals can be converted into wire. Wire means like electricity wires. But again, non-metal, if you want to convert them into wires, so they will break down. After that, lustrous. Lustrous means shiny. They are shiny or not. Metals are shiny when you polish them. But non-metals, they are not shiny except carbon in the form of diamond. So metals are shiny and non-metals are dull. Sonorous. Sonorous means something produce sound on hitting. If you hit something, it produces sound. So when you hit a metal, it produces a loud sound. If you hit a non-metal, it will not produce that much of sound. Magnetic attraction. It means they are attracted by magnet or not. So most of them, the metal, they are attracted by the magnet, but non-metal, they are do not attracted by the magnet. Any confusion in this part?
No confusion.
Okay. Now they are talking about the metallic character of in the periodic table. As I discussed with you before that, if you see the left to bottom, for example, group 1. Okay, this is the group 1. They have given here lithium, sodium, potassium. Elements on the top left of the periodic table are more metallic than those on top right. They're saying, for example, if you have group 1, this is you group 1. Next group is group 2. Next group is group 3. The elements which are here, they are most reactive. They are highly reactive. But if you will go to this side, the metals become less reactive. So if you compare the reactivity of metals, so group 1 are highly reactive metal. Group 2, they are also highly reactive, but less than group 1. Group 3, they are reactive metals, but less than group 2 and group 1. Like this, their reactivity decreases if you go left to right in a period like this. You are going like this, then their reactivity decreases. But if you talk about a single period, for example, here, lithium, sodium, potassium, rubidium, if you go top to down like this, so their reactivity increases. Their reactivity increases. Their metallic character increases. You can see here. It means that lithium is reactive, but sodium is more reactive than lithium. Then potassium is more reactive than sodium. Then rubidium is more reactive than potassium. Then cesium is more reactive than rubidium. It means that if you go down to the group, the metals become more and more reactive. So this is the general characteristics of metals in the periodic table. Again, when the metals you are talking about in the period like this, for example, here you have lithium, here you have beryllium, here you have, let's say, aluminium. So if you go to this side, So metal reactivity decreases in a period, decreases. But if you go down in one group, so metal reactivity increases. Any confusion?
No confusion.
Okay. Now we will see group 1 metals alone. We will discuss them, the properties of group 1 metals. They are saying that group 1 elements now, the group 1 elements are called alkali metals. They are called alkali metals. Why? Because when they react with cold water, they form alkaline solution. Alkaline means basic solution which has pH more than 7. So when the group 1 metal, they react with cold water, they make a solution. That solution is known as alkaline solution or basic solution. So due to that, they are known as alkali metals. If you talk about their physical properties, normally we saw that metals are hard, metals are strong, but group 1 and group 2 metal, they are exceptional metals. For example, group 1 metal, they are soft and you can cut them by a knife. They become softer down to the group as the size of atom increases. They said that as you go down in the group, for example, you sodium, potassium, you go down, say they become more softer. So lithium is less softer, sodium more softer, potassium more like this. Their softness increases as you go down to the group. And they're saying their size increases. For example, the lithium has only 2 shells. Sodium has 3 shells. Then potassium has 4 shells. As you go down in the group, the size of the atom increases. Size of atom increases. So this is the other property here. They become softer down the group as the atom size increases. Now we see the third property. What is third property? They have low boiling point and melting points. Yes, group 1 metals, they have low melting and boiling point if you compare them with group 2 transition metals, group 3 metals. Their melting and boiling point decreases as you go down to the group. For example, if you see, let's suppose I'm giving the example, if lithium has 40-degree, the melting point, down maybe you'll find 30, then down maybe you'll find 20, like this. As you go down to the group, the boiling point and the melting point both decreases to the group as you go down. And their densities are low as compared to other. Okay. Then fourth one, they are shiny when they cut. For example, if you have this sodium piece, now maybe this is not shiny, but if you cut them into 2 pieces, so you'll find the new surface which come out that will be shiny. So these are 4 properties of group 1 metals. Any confusion?
No confusion.
Okay. Now they have given here their density. For example, lithium has this much of density, potassium this. It means if you go down in the group, density decreases or increases. Can you tell me?
Increase.
Increase. Okay. Now melting point, if you go down in the group, melting point increase or decrease?
Decrease.
And what about boiling point?
Also decrease.
Okay. So these are physical properties we have discussed for the group 1 elements. Now we will discuss their chemical properties. As I said to you before, whenever they are talking about chemical properties, it means how they are going to react with other substances. Now, number one, they lose their valency electron to form ions, single ions of X type, X mean X plus. So all group 1 metals, because they have one electron in the last shell, so if they will form an ion, so that ion has a power plus 1. For example, lithium also plus, sodium plus. You can put 1, it's up to you. So it means all group 1 elements, if they form a ion, so they will lose one electron which is in their outer shell, so they will make a ion. Which ion they will form? Positive ion. Number 2, they react with oxygen to form basic oxides. So when metal react with oxygen, it will form metal oxide. For example, you can make a reaction of sodium plus oxygen. They make a reaction and they make sodium oxide. Okay, so you can put here 4 and you can put here 2. So this is the balance equation. So it means that this metal oxide, they are in nature, they are basic in nature. So number 2, they react with the oxygen to form oxides, and those oxides are basic in nature. Number 3, they react with non-metals to form salts. For example, you can take sodium. When it can react with chlorine, so it will give you NaCl, that is a salt. So they react with non-metal to form salts. They have given the example here also. Now the property number 4, they react with cold water to form alkaline solution, mean metal hydroxide, and which gas is given of hydrogen. For example, here they have given the reaction metal plus water give you metal hydroxide, and it will give you hydrogen gas. See here, we took the potassium reacting with water, giving you potassium hydroxide, and this is a hydrogen gas. So these are the chemical properties of group 1 metals. Any confusion till here?
No.
Okay. Now we will talk about group 7. Group 7, also known as halogens. Halogens. It's also mentioned here. Group 7, the elements, they are known as halogens. The group 7, they have they need one electron to complete their last shell. For example, if you talk about chlorine, chlorine total 17, in first group 2, then 8, then 7. So third group maximum can come in third group 8. So if I will add 1, then it will become 8 and last shell will be completed. And it means that if they want to form ions, which ion they will form? -1. Anyhow, see, we'll see the properties. So group 7 elements, they are known as halogens. They have 7 electrons in their last shell. They are non-metals. They are non-metals. Now we will see their physical properties. They're saying that halogens exist as a gas, liquid, and solid. You will find them into 3 states of matter. Their physical state changes go down to the group. See here, this is fluorine, this is chlorine, this is bromine, this is iodine, this is astatine. Now see, this is gas. If you go down, become liquid, then solid. So in a group, their physical state will change. As you go down, so they convert from gas to solid. Number 2, they have different colors. Their colors become more darker as you go down to the group. For example, fluorine is yellow, chlorine is green, then you have red brown, then dark gray, then black. It means as you go down to the group, color become more darker. So this is the second property. Number 3, they have low densities. Their densities increases as you go down to the group. Why? Because the size of the atom increase. So it means that fluorine has less density as compared to chlorine, then chlorine has less compared to bromine. So as you go down, their densities decreases. Number 4, they have low melting point and boiling points. Their melting and boiling point increases as you go down to the group. So as you go down, the melting point increase. Let's say fluorine has 50, then maybe chlorine have 60, then bromine has 70. Like this, the melting point and boiling point, it will decrease as you go down to the group. After that, bromine is a volatile. Volatile means something will convert into gas or vapors with at room temperature. At room temperature. For example, if you put a petrol at a room temperature, it will evaporate after some time. Now we will discuss about the chemical properties of group 7. Now they're saying that the group 7, as I told you, elements are known as halogens. So they are most reactive non-metals. When we discuss about metals, so what we said that group 1 metals are highly reactive. They are highly reactive in metals. But when you talk about non-metals, so the most reactive non-metals are group 7. So this thing they are telling here, their reactivity decreases, go down to the group as density increases. They're saying that if you go down to the group, so their reactivity will decrease, not increase. It means that fluorine is more reactive than chlorine, and chlorine is more reactive than bromine. So their reactivity decreases as you go down to the group, but the density increase as you go down to the group. Now they have 7 electrons in their last shell, outer shell. So it means that they need 1 electron to complete their last shell. And if they will get that electron, so their power will be 1 minus or minus 1. So when they will form ions, they will form like this: fluorine minus chlorine minus bromine minus like this, minus 1, because they are taking 1 electron. They are not found in alone, means not one atom. Whenever they will found 2 atoms together, like hydrogen, like oxygen. So they are diatomic molecules. So whenever you will find chlorine, it will be in this form: Cl2, fluorine F2, bromine Br2, iodine I2. Like this you will find them. Like oxygen always found in diatomic form. Diatomic, di mean 2, atomic mean atoms. So whenever they will found 2 atoms together, not alone. Like sodium can found alone, magnesium can found alone, like this. But here these group 7, they cannot found alone. Always they are in the form of 2 atoms. Number 4, they react with metal to form salt. As we discussed before, sodium reacting with chlorine and they give you salt. So this is their another chemical property. Then 5, they're saying that they react with hydrogen to form acids. For example, you have H2 and take one, the group 7 like Cl2. So what they will form? HCl. So what is HCl? It is a strong acid. Then you have H2 plus Br2. So what they will make? HBr. That is also acid. So when they react with hydrogen, so they form acids. Number 6, they react with water to form a bleach. For example, the chlorine, when it reacts with water, so it forms bleach plus acid. Bleach, you know, the Clorox you are using as to clean your washrooms, and also you are using to wash the clothes if they are white, so using this one. So when they react with water, so they form the bleach and also the acid. So this is their sixth property, chemical property. Now the uses, we will see how they can be used. So we'll talk about here the uses of group 7, or you can say uses of halogens. So halogen, they have a lot of uses. They are also used in industry. Number one, they are found in many salts. Many salts you will find sometimes chlorides, bromides, all they are used to prepare the salt. Number two, they are used in making bleach and soap. To making the bleach and soap, they are can be used. Number three, they serve as disinfectant. Disinfectant means you are used to kill bacteria and other germs, and they're using to clean toilet, and also they're used for other cleaning purposes, especially which halogen, chlorine. Now chlorine is also used to treat the water. In the air and water chapter in chemistry, they have described the water treatment, how you can make water more pure, how you can water make clean. So there is one process that is known as chlorination. Chlorination is a process in which chlorine is added to water to kill the bacteria. So it is also used to clean the water. Making mouthwash, the fluorine, it is used to make mouthwash. You remember, if you have any infection in your teeth, doctor recommend you the different like Colgate, Sensodyne, they have their mouthwash also in a liquid form. Doctor will tell you keep in your mouth for a while and then you can spit off. So that is the mouthwash, and fluorine is used there. Fluorine is also used in toothpaste because it's good for the teeth. Number six, making acids. They are used to make acid, as we discussed before that when hydrogen going to react with chlorine to give you HCl. This one we discussed now. Making PVC pipes, plastic pipes. So chlorine is also used there. Chlorine is also used to make the plastic pipes. So these are the uses of halogens or group 7 elements in industry, at home, all these things. Any confusion?
No confusion.
Okay. Now we will talk about the test for halogens. For example, if somewhere halogen is present, so how you will know, how you will test that this is a halogen. So this is, we will check it now, the test for halogens. Now, because the halogens act as bleach, so their vapors, if you will put a litmus paper, okay, on them, so what will happen? The red, blue, and universal, so they will bleach them. They will make them white. If you bring litmus paper, whatever litmus paper, on the group 7 halogens, vapors, when they in the form of gas, so they will bleach out. Bleach out mean they will remove the color. If litmus paper is red, they will make it white. If litmus paper is blue, they will make it white. If you are using any other colors, it will make it white. Okay. So other thing, if you from the vapors you want to know. So if you see the vapors and they are green in color, so it means they are from chlorine. And if the vapors are brown, it means they are vapors of bromine. And if they are purple in color, it means they are iodine. So if the vapors of halogens are coming out from any place, so from their color you can also check. Understand? So the test, how you test. So first of all, use a damp or moist litmus paper. Damp means which is wet. You can spray some water and then you can do it. So when you bring it, what will happen? As I told you, it will turn into white. Bleach means turning into white. So this is the how you will test them. Okay. Now, displacement reaction. Displacement reaction means displace mean take the place of something by other thing. So now, as I told you, as you go down in the group, the reactivity of halogen decreases. See here, chlorine and iodine. Iodine is down in the group, in the periodic table. So chlorine is more reactive than iodine. So when you make a reaction of chlorine with a compound of iodine, for example, here potassium iodide. So when it will react, this chlorine will kick out or displace the iodine. And see here, it's become potassium chloride and iodine is separated now. Same thing, bromine and iodine. Bromine is more reactive, so it will take the place, become sodium bromide and iodine again alone. But if I will make this reaction now, you have to tell me if this is the reaction, what will happen? Tell me.
KClI.
No, because iodine is less reactive than chlorine. It cannot displace chlorine. So there will be no reaction. This thing you have to keep in your mind. So if this one is more reactive than this one, then it can displace from the compound. Otherwise, no. See here, bromine plus sodium chloride, no reaction. Because chlorine is more reactive than bromine, it cannot displace it. So this thing you have to keep in your mind. Any confusion?
Yes, can you repeat this again?
I'm saying that if you see the periodic table in group 7, you will find here fluorine, then you find chlorine, then you find bromine, then you iodine. So as we discussed before, if you go down, reactivity decreases. Reactivity decreases. Fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. So by keeping this thing in your mind, when chlorine is making a reaction of a compound in which you have iodine, so chlorine will come and kick out iodine and take its place. Why? Because chlorine is more reactive than iodine. But if you make this reaction like this, for example, KCl plus iodine, so now iodine can take out this chlorine? No, because chlorine is more reactive. So no reaction will happen. Nothing will happen. It will remain like this.